back to my YouTube channel. So today we are going to solve day 27 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 3381. Maximum subarray sum with the length divisible by k. So in this problem you are given an array of integers nums and an integer k. We have to return the maximum sub of a subarray of nums, right? And what is subarray? A subarray is a contiguous non-empty sequence of elements within an array, right? So we have to return the maximum sum of a subarray of nums such that the size of the subarray is divisible by k, right? So problem statement is very easy, right? So we have just given some array of integers nums, right, and integer k. So we have to return the maximum sum of subarray of nums. So what are different subarrays first? So different subarrays can be this empty, can be this one, can be this two, can be this one, two, right? So we have to return the maximum sum of a subarray of nums such that the size of the subarray is divisible by k. Size 0 is divisible by k. 0 is divisible by k. Yes, we can just simply return 0, right? Here this is also divisible by 1. This is also divisible by 1, right? Size, here I'm writing size. This one is also divisible by size, by k value, right? By k value, by k value, by k value, right? K is equal to 1, 1, 1. Okay, so here I'm writing length. This is length, this is length, this is length, right? So size of all these subarrays is divisible by k, right? Right. Now here I'm getting sum as 0, here I'm getting sum as 1, here I'm getting sum as 2, here I'm getting sum as 3. So where I'm getting the maximum? I'm getting the maximum here, right? So that's what I have to return. So maximum here. That's it. Okay, so we have to return 3. Okay, so let's say this is my example, minus 10, minus 1, and k is equal to 1. Tell me what is going to the output. So different subarrays possible is empty subarray, right? One empty subarray is possible, right? It is not given, right? Return the maximum sum of a subarray. Is it saying that it should not be empty anywhere? I don't think so. It is not saying, right? So this is done. Then here this is also possible, this is also possible, and this is also possible, minus 10, minus 1, right? So all are possible, right? Because here length 0 is divisible by 1, length 1 is divisible by 1, length 1 is divisible by 1, length 2 is divisible by 1. All are possible. Here I'm getting sum as 0, here I'm getting sum as minus 10, minus 10, here I'm getting sum as minus 1, here I'm getting sum as minus 11. So tell me among them what is max? This is max, right? So we have to return minus 1 as the output for this one, not minus 11. Okay, clear? Same way here, if you see this example, k is equal to 4, right? So k is equal to 4, so we have to just find out all the subarrays, right? All the subarrays. In all those subarrays, right, when length is divisible by k, right, this is what we need to make sure, and we have to find the maximum as also. So if you notice in this case, so length is 4, right? Length is equal to 4, and 4 is divisible by 4, right? Completely, right? 4 modulus with 4 is equal to 0 only, right? And what is the sum of this? So minus 1, minus 2, minus 3, minus 3, minus 3, minus 6, minus 6, minus 4 is minus 10. So we are returning minus 10 here, right? So you can try some other subarrays of length 4. So you will find out that this is the max only, right? Okay, now see this example number 3, right? So now here, if you see in this example, right, if you see in this example, so first thing what we need to do, right, every time we have to do the summation, right? Sum of all the elements in the subarray. This is what I'm doing, right? What I'm doing, I'm calculating the sum of all the elements in subarray, right? And you know one thing, that what is subarray? A subarray is nothing but a continuous non-empty sequence of elements within an array, right? So instead of finding the sum like this, right, one by one iterate over all the elements and then calculate the sum, and next time if you pick some other subarray, right, 2, minus 3, minus 4, it is a continuous only, right? Again you are going to do the summation starting from here to here, right? Or if you pick the subarray like this, minus 1, minus 5, 1, 2, minus 3, this is also continuous. Again you are going to do complete. Or next time if you pick -5, 1, 2, -3, 4, then again you are going to calculate the sum of all the elements. So we need some shortcut here, right? I need one shortcut. So in such a way that I know that if I am here and last time I am here, so in this range I will get the sum directly in of one operation, right? I need some shortcut. So here I am talking about nothing but prefix sum. Prefix sum, right? So this is the first thing that we need to do. So let's take this same example, right? I will show you. So here this is your nums array, right? Nums array is like this: -5, -1, 2, -3, and 4, right? This is your nums array. Okay, and here if I just give the indexing of this nums array, so I can say this is nothing but 0 index, 1 index, 2 index, 3 index, 4 index. So how we calculate the prefix sum, right? How we calculate the prefix sum? So initially my prefix sum is always going to be 0 only initially. Then next time what we do, 0 -5 is -5, -5 -1 is -6, -6 plus 2 is -4, -4 -3 is -7, -7 plus 4 is -3, right? This is how we calculate the prefix sum, right? This is how we calculate the prefix sum. And here if I just write indexing 0, 1, 2, 3, 4, 5, right? So if you notice here, nums is having length 1, 2, 3, 4, 5, right? And length is equal to 5. And my prefix sum is having n plus 1 as a length, right? 6, right? If my n value is equal to 5, so my length is 6 here, right? Clear? And what does it show? What does this index show? So this index show, I can say, prefix at I plus 1. Let's say I plus 1. Okay, so it is nothing but it is showing the previous prefix of I value plus this value, right? Nums of I value, right? So I am doing what? These two I'm doing the plus and then writing the output here, right? Then prefix of I, this, plus nums of I, I'm doing the summation and I'm writing it here, -6. -6 plus -2, I'm writing -4. I'm doing the addition of this, writing it here. I'm doing the addition of this and I'm writing it here. I'm doing the addition of these two and I'm writing it here, right? So this is how you have to fill the prefix, right? Now how it is helpful, okay. Now here let's see, I want you to give me the sum of this, give me the sum of this, right? So instead of iterating over all the elements, right, like -5 plus 1 -4 -4 plus 2 -2 -2 -3 -5. So instead of calculating a sum like this, iterating over this, now if you have already calculated the prefix sum, then it is going to be very easy, right? It is 1, it is not -1, right? So we have to correct something, right? So -5, it is 1, 2, -3, 4. Okay, so let me fix it quickly. So this thing is 1, this thing is 1, right? So -5, 1, so we have to correct this, right? -5, that's why I'm saying wrong. Okay, so -5 plus 1 is -4, right? -4 plus 2 is -2, right? -2 -3, now I'm getting correct, right? Here -5, right? -5, and -5 plus 4 is equal to -1, right? So I hope that I'm correct now. So -5, 1, 2, -3, 4. So 0, -5, -5, -5 plus 1, -4, -4, 2, -2, -2, -3, -5. Now it's correct. Okay, so yeah, -5. Okay, now it is correct. Now it is, we are getting this if we do the normal. Now if you see the shortcut, right? So here this at 3, right? So in nums of I, it is 3, right? But here in prefix I am checking I plus 1, right? This is 4, right? This is 4, here this is 3. So add 4, and here starting from 0, right? So starting from 0, so here just check before 0, until here. Okay, so what I'm saying, I know I want to calculate the sum in this, right? Sum in this. Let's say this is my left, this is my right. Okay, in this range I need to find out the sum. So in prefix, at prefix I plus 1 actually, I have this, right? And here just before this L, let's say at this particular position, right, I have one sum, right? I have some sum. Okay, so this until here, this is a sum of complete, starting from initial point to until here, this is a complete sum. Now if I just remove this sum, right, from this, if I remove the sum for this part, right, for this part, then I am left out with the sum of this part, right, sum of this part. This is actually what we need, right? So here if you see, add 3, so just do what, just do here prefix of I plus 1, I plus 1, so, because here I is this in nums, it is pointed to this 3, so I'm writing here 4, right, minus here it is 0, right, it is 0, so you can simply say prefix of I, right, you can say prefix of I, because here I'm starting from 0, right, so I can take it, I can take it, because here this 0 actually, this is nothing but this 1, so I can simply write it like this. So prefix of 0, and here you can write 4, right, for this one. So 4 minus 0, so minus 5 minus minus 5 minus, and here 0, right, so you are going to get minus 5. Minus 5 is the output. Let me prove it for some other example as well. So if I ask you to calculate the sum of this, right, so if I just give 0 1 2 3 4, so I want sum this, so just do here prefix of from here now at 4, so just write 5 here, 4 plus 1 5, and here starting from 2 now, so just write a prefix of 2, prefix of 2. Why I'm writing just prefix of 2? Because here first just let me show you total sum. 2 minus 3 minus 1, minus 1 plus 4 is 3, right, so 3. So let's see if this prefix of 5 is nothing but prefix of 5, prefix of 5 is minus 1. Okay, minus 1 minus, and prefix of 2, prefix of 2, prefix of 2 is a minus 4, right, so here minus 4. So now that simply means minus 1 plus 4, that is nothing but 3, so we are getting 3 here. Yeah, it is correct, right? So why I'm writing here just prefix of 2? Because prefix 2 is nothing but it is showing the sum until this element, until this element, right, and prefix of 5 is showing the sum until this element. And what we need until this part, right, it's 2 3 4, right, so that is correct, 2 minus 3 4. So I hope that this is clear. So this is the first thing that we need to do, right, calculate the prefix sum. All right, now this is done. Okay, so now let me just write the same example one more time. Next thing what we need to do, next thing what we need to do, right, so here let's suppose uh, k value is 2 only, right, let me double check again. K value is 2 only for this example, right? So now if I am here, okay, let's say my subarray ending here, right, so k is equal to 2, right, k is equal to 2, k is equal to 2. Okay, so for this one, if my subarray is ending 1, so this is completely divisible by 2, right, of length 2, this is completely divisible by 2. Same way this is also divisible by 2, right, both are divisible by 2, right, clear? Now if I ask you how I'm going to calculate the length of these two subarrays, so you can simply say na prefix sum at this subarray 4 na, so here you have to write 5, right, so 5 minus, here you have to write p of 3, right, p of 3, starting from here na, p of 3 you can write, right, this I have already explained above. Same way one more case, p of 5 minus p of 1, right, these two are the possibilities, right? So I am just saying ending at this position, ending at this particular position. Okay, so here this thing is fixed, this is thing is fixed, right? So here I will get some value, here I will get some value, right? And you know what we need? We need the maximum sum, right? Maximum sum, we need maximum sum, right? So for this to be max, for this value to be max, I need this value to be minimum, right? Because I'm subtracting this value from this which is fixed, which is fixed. So I want this value to be minimum. Okay, this is what I need, right? Clear? Okay, so here if I just calculate the value, so at p of 5, right? If I just calculate the sum, okay, let me show you the sum as well. So for this one, p of 5, at p of 5 we have -1, and p of 3 we have -2. So minus 2. So we are going to get -1 plus 2, we are going to get 1. So this is correct now. For this one sum is 1 only, right? -3 plus 4. Okay, now same way here if I want to calculate. So p5 is -1 minus, and p1, at p1, p1 is nothing but 5, -5, right? So -5. So I'm going to get -1 plus 5. So that is nothing but 4. I'm getting 4, right? I'm getting 4. So here tell me, here tell me. Okay, so for this one I'm getting 4. So we need maximum, right? What we need maximum, right? So 1 2 minus 3 4, right? This is also valid, right? This is output actually. So here we are getting max, here 4, right? So to get this 4 as maximum, here at this particular position I'm using what? I'm using a minimum value. So -2 and -5, what is minimum among them? -2 and -5, minimum is -5, right? So that's what I need to use. Okay, all right. So somehow here actually what I need this value to be minimum, right? I need this value to be minimum. Okay, this value to be minimum. All right. So and how we calculate the length? How we calculate the length? We calculate the length like this of subarray, r minus l plus 1, right? This is how we calculate actually length, right? So this length also it should be divisible by k. This is what I'm saying, right? So here let's say this is your left pointer, this is r pointer. So r minus l, okay, 4 minus 3 plus 1. So it is nothing but length is 2. So 2 modulus with k is equal to 0, right? Correct. Same way this length if you want to calculate, 4 minus 1 plus 1, that is nothing but 4. 4 modulus with k is also equal to 0. Okay, so this is how we calculate the length, right? I can also write it like this, r plus 1 modulus with k, right? And is equal to l goes this side, so l modulus with k, right? I can also write it like this, right? Okay, so this part, this part, this part, r plus 1, I'm doing r plus 1. So I can say that this part is nothing but my I will calculate the prefix of I at this particular position, right? Prefix of I at this particular position, right? And this part, right? This part is nothing but L modulus with k, right? So L modulus k, right? So L modulus k. So right is fixed, right is fixed, let's say. Okay. Now L modulus k. L modulus k means this part I'm talking about this part, right? If I just take this part to other side, right? So if this part, right, I'm dealing with. So for this part, every time remainder should be same actually. Remainder should be same, right? Remainder should be same, right? Here if you see, I am taking what? I'm taking 3. So 3 modulus with k is equal to 1. Here also 1 modulus with 2 is also equal to 1. So for all the elements here remainder is remaining same only, right? And here I'm taking L modulus with k, right? L modulus with k. I'm getting some remainder only, right? If I'm doing the modulus. So this side remainder should be same, right? Of all the elements. That is the pattern actually. That is the pattern you notice, right? So here if you see, uh, if you are here, next time you are making a k jump, right? You are making a k jump. So initially you are uh, here, okay, initially you are here, right, at 1. Next time you are making a jump of k, 1 plus k. So 1 plus k, next time you are 3, okay. Next time after that, if you have subarray of length 5 and 6, okay, so next time if you are here, let's say x element, y element, and for this if you need, so then this is one you need to check, this is one you need to check, okay, which are divisible by, and this, okay, these are the things that you need to check. So here 1 plus k, and then next time 1 plus 2k. So every time you are making a jump, right, of k times. So if this is whatever the remainder of you are going to get for this one, okay, same remainder you are going to get for this one and this one, right? Clear? So let's say k is equal to 2, so 1, then 3, then 5, right here 5. So all if you do the remainder, calculate the remainder, you will get the same remainder for all these elements, that is nothing but 1, right? Okay, so this is example when your I is at 4, right? When your I is at uh, starting from here, right? So let's say if I ask you to start from here, so next, so here in that case, uh, this will be first element and this will be the one subarray, right? If you start, if for subarray ending here, so you are going to check this and this, right? So here also if you see now, if you are starting, okay, if you are here 0, next time you are going to make the jump to 0 plus k 2, right? So and for both of them the remainder is 0, right? Remainder is 0. So in this side, remainder is always remaining same only, right? Remainder is only going to remain same only, right? So for all the same remainders I will keep track, right? For all the same remainders, this one also same remainder, this one also same remainder, for all the same remainders I will keep track of the minimum value, min value. That is what I'm trying to do, okay. So if I have the minimum value now, so I will get the max output, so I will store the max output here, right? So this is the plan, okay. So let's write the code, right? Whatever we know as of now, and I will also explain the code side by side, okay. So here what you need to do first, calculate the length of nums, right? Int n is equal to nums dot length, right? And then you have to calculate the prefix as new long, and here you have to write n plus 1, okay, done. And then after that you have to fill out all the values. Int I is equal to 0, I is less than n, and here I plus plus, and here you have to write prefix of I plus 1 is equal to prefix at I, and here plus nums of I, right? So this is how we are calculating the prefix, this you already know, right? And now here I'm going to create one prefix array, min prefix, right? So here for k is equal to 2, only two remainders are possible, 0 and 1, right? So for this I'm going to create a min prefix named array, right? And here I'm just going to pass the size as new long k, right? This is what I'm going to do. And here one more thing, right? So how this is helpful actually, why keep track of minimum. So it's not like if you do search, find the sum of this, then find the sum of this, there may be a lot of before this, there may be lot of, right? In worst case scenario, if your k is equal to 2, then you may check of n elements every time. For this index of n elements, previous of n subarrays, right? For this one also you have to check this, right? So in that case you will get a time complexity of n square, which is not valid for this problem, right? That is wrong, because here you will get time limit exceed error, right? So that is the reason that this logic is working, right? This logic will work. That's why we need to calculate something like this, okay. So now let's write the code further, okay. So this is done, and here initially just fill all the values with the max, right? Arrays dot fill min prefix, okay, and here long dot max underscore value. So this is the initial setup, right? So here in this side I want minimum values, right? So initially I'm giving max only, right, so that I don't get the good result, right? But I need minimum, so later on I will update it with the minimum, right, so that I will get max like this. Okay, so this is done. Now here we have to return the answer in long, right? So create one variable long, answer is equal to long dot main underscore value, right? And then after that here just run one loop for int I is equal to 0, I is less than equal to n, and here I plus plus, and here just calculate the remainder as nothing but I modulus with k, and here just check if min pref of remainder, right, is not equal to long dot max underscore value. So if it is equal to max value, then definitely we are not going to get some best result, right? So in that case, if it is not, then my answer is going to be updated as math dot max of answer comma prefix of here I minus main prefix of remainder, right? Like this I will update, right? So here I'm keeping track of the max best answer, and how I'm calculating the answer as prefix of I minus min prefix of the remainder, right, common remainder, and this I have to update every time, right? So here I'm just going to write min prefix of remainder as nothing but this. Here I'm just storing the minimum value every time, right, for all the indexes. So math dot min, right, here min prefix at this particular remainder and prefix of I, right? This is how I'm going to update. That's it. And here I'm just going to return answer. That's it. This is your code. Okay, so now let's run it. Let's see if there is code issue. We'll try to fix that. So yes, there are some issues. So here what are those issues? So here I'm writing prefix now, complete prefix I'm writing. So can I change it to pref only? Okay, now let's run it. So see, all the test cases has been accepted, right? And I let me show you one more example here. Actually I think I discussed it in the starting itself. So for this one, what is going to be your output? Your output is going to be -1, not -11. See, output is -1. Okay, so we need to return the max sum also, right? So let's submit it. So see, our solution is accepted, right? And what is going to be the time complexity for this one? So time complexity here I'm just iterating over of n elements, right? And here also I'm iterating of n. So of n is the time complexity, right? So I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in the comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.